Hi everyone, today we are discussing operations on stack and queue data structures. The stack is a non-primitive linear data structure. That is, it is not a built-in data structure, but rather implemented with the help of other data structures. And by linear I mean that the elements are linked one after the other. The stack has a single pointer called the top. Addition of a new element or the deletion of an element takes place at the top. The stack is also called a LIFO, or a last in first out type of list. The last element added to the top of the stack will be the first one to be removed from it.
Let me add to that. Whenever a new element is added to the top of the stack, the value of top is incremented by 1. And also, the top is decremented by 1 when an element is deleted from the stack.
That's right. Now, the insertion is called push and deletion, POP. Now let me quickly tell you about push. Firstly, we check if the stack is already full or stack overflow. If not, we increment top by 1 and set the value of top of stack. Whenever we reach stack overflow, we will be stopped by the operation. We could then no longer add any more elements.
I'll tell about POP. In POP, we check if the value of top is less than 0. If yes, we say stack underflow. If not, then we store the element at the top position, away and return it, and decrement the top by 1.
Exactly. Moving on to queue now. The queue is similar to stack, but here the insertions happen at the rear of the queue and deletions at the front of the queue. So it's known as a FIFO, first in first out, list.
When the queue is empty, the front and rear equal to -1.
Exactly. Let's get right into insertion here. Firstly, we set front and rear to -1. If the queue is full, we say that queue overflow. Otherwise, we increment rear by 1 and set the value of rear position of queue. When the first value is inserted, we set front to 0. After that, front is not changed. Now after inserting all elements into the queue, and we try to add one more, we get the queue overflow error.
Let me end this session by talking about deletions in queue.
Go ahead.
Firstly, we check whether the queue is empty or not by checking if front equals -1. If no, we then also check if the queue has a single element only by seeing if the value of front equals rear. In the case there is only a single element, after storing away the last element, I'm talking about the element at the front position, we again set front and rear both to -1. All other times, we store the element in the front position away, and return it, and increment front by 1.
Well said. Thank you for attending this session. Hope stacks and queues were clear to all.